solve for b. We have the square root of the quantity of 2 minus 4b equals 2 times the square root of the quantity 3 minus 8b. How am I going to solve for b when there are radicals on both sides of my equal sign? My teaching assistant Chloe is here with her latest tips and tricks. She wants you to know that you always should check your answers to see if you have a real solution or an extraneous solution. Real solutions, when you check it, the left side will equal the right side, and on extraneous solutions, when you check it, the left side will not equal the right side. Now that we have my teaching assistant Chloe's tips and tricks, we can go ahead and start working on solving for b. So the first thing is I have radicals on both sides. In order to get rid of a square root, you have to square both sides. So on my left-hand side, my square root and the square will cancel out. But on my right-hand side, I can't just do that because I have a 2 in front. So what I'm going to have to do is expand that. So when I do this, the left side is just 2 minus 4b because the square root and the square cancel out. On the right-hand side, we have 2 times the square root of the quantity 3 minus 8b, and this whole entire thing is squared. So we're really multiplying it by itself twice. Then from here, you can see that this 2 times 2 ends up equaling 4, and the square root of 3 minus 8b times the square root of 3 minus 8b, when you have like radicals, they have the same index or root and the same radicand, you can multiply them by each other and just write what's in the radicand as the answer. Now from here, I'm going to go ahead and distribute this 4 to the 3 and then the 4 to the negative 8b. So I have 2 minus 4b equals 4 times 3 is 12. 4 times negative 8b is a negative 32b. Now I'm going to go ahead and solve for b. So I'm going to move my b's to one side and my numbers to the other. I'm going to start by adding 32b to the other side. When I do that, the 32b's will cancel out on the right, and I get 2 plus negative 4b plus 32b is a 28b equal to 12. Then from here, I'm going to go ahead and move my 2 to the other side. When I do this, 2's will end up canceling out on the left, and I end up getting 28b equals 12 minus 2 is 10. Then I will divide by 28 on each side. 28's will cancel out on the left, and I end up getting 10 divided by 28. Now I can reduce that. 10 and 28 can both be divisible by 2. 10 divided by 2 ends up equaling 5. 28 divided by 2 is 14. So I got my answer that b equals 5 over 14. Now I need to check, according to Chloe's tips and tricks down here, they let us know to always check our answers when we are dealing with radicals. We have to find out if b equals 5 over 14. Is this a real solution where we're going to box it in, or is this an extraneous solution, meaning it's not a real solution? If it is real, when we plug this in, the left side will equal the right side. If it is extraneous, the left side will not equal the right side. You can get real solutions. You can get real solutions and extraneous solutions in the same problem. You can even get a problem that has nothing but extraneous solutions, meaning there's no real solution whatsoever. So you never know what's going to happen until you actually check your work. So I go ahead and I'm starting to check it. So I took my original equation, the square root of 2 minus 4b, and I plugged in 5 over 14 for that b. On the right-hand side, I have 2 times the square root of 3 minus 8b, so that's 3 minus 8 times 5 over 14. Now from here, I can reduce a little bit more. When I am multiplying this 4 times 5 over 14, I can cross-reduce. So this 4 divided by 2, that would be a 2. 14 divided by 2 is 7. And I also know that this 2 is a whole number, but to make it a fraction, I can put it over 1. This 3 over here, I can make it into a fraction by putting it over 1. And 8 and 14, I can actually reduce those as well diagonally. 8 divided by 2 is 4. 14 divided by 2 is 7. So when I write this all nice and neat, I really have 2 over 1 minus 2 times 5 is 10 over 7. Then I have 2 on the outside, 3 over 1 minus 4 times 5 is 20, all over 7. Then from here, I just have to find a common denominator when I am adding or subtracting. So a common denominator between 1 and 7 would be 7. So I would multiply 1 by 7 to get that denominator. And then whatever you multiply the denominator by, you have to multiply your numerator by it as well. That would be 2 times 7. Same thing over here. Common denominator between 1 and 7 is 7. So I'll multiply this by 7 and I'll multiply my numerator by 7. When I end up doing that, 2 times 7 is 14. 1 times 7 is 7. So I have 14 over 7 minus 10 over 7. On the right-hand side, I still have the 2 in front. 3 times 7 is 21. 1 times 7 is 7 minus 20 over 7. You can add and subtract fractions once they have the same common denominator. So from here, I can go ahead and reduce this a little bit more. I have 14 minus 10, which is 4. 7 minus 7, the denominator 7 is already the same, so I can just write that. On the right-hand side, I have the same common denominator of 7. And in my numerators, I have 21 minus 20, which is 1. From here, I can go ahead and see that the square root is of a fraction. So that means I can break the radical sign into both the numerator and denominator. And I did that on both sides. Now the square root of 4, that's a perfect square. That's just going to equal 2. And square root of 7 in the denominator. Over here, I know the square root of 1 is 1. And 1 times 2 is 2, all over the square root of 7. Now, I know that this is not the proper way to write a final answer, but I'm just doing a check. I just want to see if the left side equals the right side. And since I can now really visualize this, I can see it now, I know, therefore, b equals 5 over 14 is a real solution. So this is the answer to my problem.